Welcome to the Roots of Research, where we go behind the publications and dig deeper with Georgia Southern faculty. I'm your host, Dr. David Weindorf, and today I'm thrilled to be joined by Dr. Stetson Rowles, an assistant professor of civil engineering at Georgia Southern University. Dr. Rowles earned his master's degree in environmental and water resources engineering and a doctoral degree in civil and environmental engineering, both from the University of Texas at Austin. Hook 'em. He then completed a postdoctoral appointment at the University of Illinois Urbana-Champaign. His research focuses on developing sustainable engineering solutions at the intersection of technology development and practical implementation. Welcome to the show, Stetson.
Thanks so much, David. Yeah, really excited to be here.
It's great to have you here, truly. Well, listen, let's start at the beginning. First of all, I want to know, and our listeners want to know, what brought you to Georgia Southern University, and how did you decide to focus on water conservation, environmental sustainability, and resource management?
So I guess let me start where I first got into kind of research and, kind of led me down this path. So I wanted to become an engineer, particularly a civil engineer, because I liked math and I wanted to be outside. And I was going to focus on geotechnical engineering because I have a passion for clay and ceramics. But really it was two classes from one professor that kind of changed my whole trajectory. So in my second to last semester, I took two classes from a faculty named Dr. Naveed Saleh. Okay. One class was an engineering design class, fairly standard. The other one was a novel class that he had kind of started around environmental implications and applications of nanomaterials. And it really opened my eyes to research, what it meant to do research, opportunities with environmental engineering, what exactly environmental engineering was. And the class itself was structured in a cool way because it was very interdisciplinary. There were some folks from public health and a faculty from public health. There was someone from education and students from education that were involved as well. And through that, the class was actually sponsored by NSF, okay. And then there was actually a research experience component of it as well. So the engineering students got to travel to the Navajo Nation as part of the class.
Excellent.
Where we learned about 40 plus years of uranium mining. And through that trip, that's where I really started to have this eye-opening experience. And I really got to know Dr. Saleh a lot better, too.
Yeah. Tell me a little bit about that relationship with Dr. Saleh. Like, were you working as a technician in this lab at all? Or?
Not at first.
Okay.
So it was after that trip that I was basically like, hey, I'm interested in research.
Right.
Can I work in your lab?
Sure.
So had the opportunity to start basically volunteering in his lab, started at the bottom, right? Washing dishes and starting to do some very basic experiments, but they were the most exciting, times basically of my undergrad.
Yeah.
And the PhD students that were mentoring me as well really had a passion for research and kind of, taught me and guided me along that as well. So that was a really valuable experience. And since then, they've become great colleagues and continue to work with them.
Absolutely. I can relate to that because I will just also say I also started washing glassware as an undergraduate. I think that's a common experience, but it gets you in the laboratory and it gets you around those scholars, and it's so important.
Yep. And then that next semester, my last semester, it actually turned out Dr. Saleh got a new job at University of Texas at Austin, and the opportunity came up to go to a graduate school and follow him there, basically. So, overall, I would say like my trip into research kind of led me down this just in terms of an opportunity, and then also seeing the teamwork in the lab. Yeah. That was something that was really cool for me. And at University of Texas, I got to pick up another advisor, Dr. Des Lawler, so I was co-advised between the two, which was a really interesting thing because Dr. Saleh was fairly new, tenure track, very enthusiastic, really had that drive, kind of needed to succeed, right? Whereas Des Lawler had been there, I don't know, maybe 30 years or so. Okay. So, was more of like the wise, slow moving, but in incredibly seasoned and knowledgeable advisor for me.
Brings that authentic wisdom to the table.
Yep. Yeah. And it wasn't all easy. That's the thing I too want to point out. The grad school, especially the first year, was incredibly difficult for me. Sure. I was thinking about this the other day as I was talking to a new grad student. And, I struggled on tests. I struggled on homeworks. Mm-hmm. I actually had nightmares about the tests that we were going to have the next day. I remember vividly this nightmare about ionic strength before water chemistry tests the next day. But what I tried to do is just stay optimistic, right? So, I walked into campus, and I remember especially that first year, on my walk into campus, I would listen to the song "I Will Survive."
Oh, nice.
And I felt like that really like kept me going. And that built up that team around, my advisors, around the community there. And I think that kind of led me towards this path of research.
Absolutely.
So just jumping at those opportunities and trying to stay positive.
That's amazing. That's so fascinating. Well, there's so much to unpack here. I want to come back to your experiences of the Navajo Nation in just a moment. But before we get to that, can you break it down for us a little bit in terms of what you actually do in advancing innovative water and environmental technologies that address real world challenges? Give our listeners some idea about what this looks like in the real world. I mean, what is this all about?
Yeah. So those statements really sum up what our research group does. But what it kind of really means is that, a lot of engineering and solutions, we chase these silver bullet solutions, right? Do you know what the silver bullet?
I do not. Yeah, go ahead.
Silver bullet solution, the silver bullet kills the werewolf every single time.
Okay.
So it's a technology that says, this is the solution. It will work everywhere. It will, it is the answer.
Yeah.
As an engineer, I don't believe in silver bullet technology. So, what we try to do is instead try to get outside of the lab, understand context, really try to learn about those solutions that make sure they're technically sound, but also they make sense for the people and the places where they're going to be used. So we also try to develop technologies, things like water filters for safer drinking water, maybe, modeling or digital twins of different wastewater processes. But we always try to pair these with more practical side. So either through field work, partnerships with industry, or really even community input. So we use a process sometimes called quantitative sustainable design. And my postdoc advisor kind of developed this process. It aims to use process modeling, so we understand, a technology functionality, but we layer on tools like techno-economic analysis, where we estimate costs, and tools like life cycle assessment to understand environmental impacts. And it's our way of asking not only is this going to work? It's also trying to ask, is it going to work, or does it work here in this context, these constraints, these stakeholders? So is it not just affordable, but can it be sustainably adopted?
Sure, absolutely. And working with industry, cost analysis is so important. We know that. They don't want to necessarily implement something if the cost savings aren't going to be there. So that's really an important aspect of it. So I want to go back to this aspect about working with the Navajo Nation. And I know that's had a profound impact on you and your career. You talked about, working with some of these different materials. And I know often Native peoples work with localized materials like clay and pine resin and things like this. You've sort of had a hybrid approach between using those and also nanoparticles and other things to create these dynamic filtration systems. Talk a little bit about that work.
So, ceramic water filters are an existing technology, basically. We didn't necessarily come up with it. But what we were trying to do, so the ceramic filter itself is a porous ceramic matrix that can filter out particles, like a Brita filter or like physical removal, basically. And then they're usually coated with silver nanoparticles, which kill bacteria, right? The silver ions dissolve. But right now, the way that they're used in the 40-plus factories and coated in 40-plus factories around the world is that immobilization isn't considered at all. So that's kind of what we were trying to do, or had in the back of our mind, I guess you could say. And my advisors and I started working with a Navajo potter, Deanna So, and that relationship kind of stemmed from that first trip to the Navajo Nation during undergrad and kind of percolated through, a relative or a friend of a friend. And she's a third-generation potter. Okay. And we worked directly with her. And we had this idea about ceramic water filters kind of in the back of our minds. But when we visited with her, we really tried to go in with no agenda. We just wanted to learn from her. What are the materials she uses? How does she use them? What are those techniques that are passed down from the generations above her? And that really helped us, with her help and guidance, form our hypotheses. So we went out and we collected pinyon sap, which is pinyon pitch from these pine trees that grow, and they use that for glazing pottery to make it non-porous, basically. Well, we thought of basically, can we use a little bit less of that so it's still porous, but maybe immobilize the silver nanoparticles? Nice. And it was a really interesting study because we were able to address the immobilization, but we were also able to overcome some of the chemical functionality and limitations of silver nanoparticles. So silver and chloride, silver and sulfide are good friends. They have a strong affiliation, right? So silver nanoparticles can become passivated, so they're not able to dissolve. And that pinion resin essentially prevented that chloride and sulfide from interacting with the silver nanoparticles, prevent that poisoning, basically.
So using these natural materials with a contemporary use,
Yep,
basically.
exactly.
That's truly incredible. And some of this work was also featured on Nova, was it not?
Yes, yeah, that was a really cool experience.
I can imagine. Yeah, I remember watching some of that on PBS. So yeah, really, really nice. Just briefly touch on the cultural aspect of what it was like working with the Navajo Nation and some of those folks. I mean, I know when I've worked with Native American peoples, I always learn more than I even go there to convey.
Yeah.
Just all that wisdom handed down over thousands of years. I mean, it must have been awe-inspiring.
Absolutely. Yeah, and I think there's a term that I like to use a lot of times for working with not only Native communities, but communities in general is underestimated communities. Because I think as engineers, scientists, sometimes we underestimate that knowledge, that value that local people can really bring towards a technology, towards a solution, towards something. And, like you mentioned, underestimating what they actually know, right? It may not be knowledge in a textbook, right? That you can go and look up and, this cited paper or whatever, but it's learned through years and it's learned through practice and it's learned because it works.
Yeah. I've often found that a lot of their experiences, their lived experiences, align very nicely with what we study in science. And then you find commonality between those lived experiences and what we also discover in the scientific community. So that's wonderful. Hey, speaking of community engagement, now you've emphasized the importance of affordable, open source monitoring tools. I'm going to throw an acronym at you. AQUIC, right? The Aquatic Quality Watch Informed by Communities Project. Tell me more about that and how local communities engage with these kinds of tools.
Yeah, so I really appreciate the opportunity to talk about this project because it is a really fun project. It's ongoing, and I think the community engagement side is really kind of the piece we're still working on, and there's still a lot of work to do. This project was interesting in the way it started. So it was my first semester here at Georgia Southern teaching fluid mechanics, and I had a student that came up, Josiah Hacker, and said, "Hey, I'm an honors student, and I like your class, and I want to, potentially do my honors thesis with you." I was a brand new faculty. I didn't really know about the honors program here, what it meant to do an honors thesis. I'm still trying to figure out how to teach, how to get my lab started, things like this. I said, well, our lab's brand new, so, we don't have any equipment. We don't have anything going on. I have this idea about, using and trying to look at sensors that are openly available online. So basically sensors, water sensors that you can buy. I don't think they've been really tested that much from an environmental engineering perspective. And he took the project to the next level. He did a great job kind of developing these sensors, building them based on multiple different instructions online, putting them together, and actually included several other students in it as well. So he had this little kind of cohort that he developed. And it was from that honors thesis that we actually applied for a collaborative funding opportunity through a program called 100K Strong in the Americas, with some colleagues of mine in Colombia, South America, that I went to grad school with. And we ended up getting the project, and it was really an exchange between folks in Colombia, 2 institutions in Colombia, and then Georgia Southern University. So some of those students came here and faculty came here, and we got to go down there. We got to test out how these water sensors work in these different environments, developed modules in English and also in Spanish. We put it on the Instructables page. If you don't know about Autodesk Instructables, there's instructions on how to do everything on there, basically how to make a peanut butter and jelly sandwich. You can read about it. But yeah, so it got picked up on there. It's been viewed a number of times. But I really think that the community engagement is something that we're really continuing to work on through a cycle, right? So we're testing it, trying to put it out in the community, see how it works, collect feedback, and then kind of an iterative approach to it.
And you've remained strongly engaged internationally, even from that. You were saying that happened the first couple of semesters that you were here, but ever since then, you've been strongly connected internationally as well.
Yes, yeah, and I think that the international collaboration brings a lot of value. I think you've mentioned it before from not only a citation standpoint, But also for me, what I've found is really value in kind of trusting those local partners, right? So, working with the folks in Colombia, they really know what works there or what may work there, what tools are actually available there. For instance, we bought a lot of those materials off Amazon that may not be available there. Exactly. So we found a distributor, abroad that can send them directly. So there's a lot of value, I think, in that collaboration, and really it's needed, I think, to move fields forward.
Yeah, learning from each other. I love it.
Yep.
That's fantastic. In so many ways, your research works to surmount regional water management challenges, right? Whether we're talking filtration or movement or other things. So what makes the coastal plain such an important and complex test bed for looking at things like water efficiency?
Yeah, I think a fewfold. One, I think this is a really exciting place because Georgia Southern, has so much growth, so much enthusiasm, so much, wind in our sails, basically. And I think that's really exciting. But also, so does this area. And I think there's some shifts going on in this area. We have one project now sponsored by the Georgia Environmental Protection Division that's looking at water efficiency in this area. And we're kind of trying to take this approach where historically Southeast Georgia is thought of having plenty of water, humid. We have the Floridian aquifer, right? But we're seeing mounting pressure on our Floridian aquifer with saltwater intrusion, maybe with over reuse and things like that. So I think there's some interesting questions to be more forward thinking here that there are additional solutions. So for instance, there's a lot of places out west, Texas and California, that have started these reuse programs, right? So they're basically connecting wastewater treatment plants with drinking water treatment plants. And that might not be the solution here. I'm not saying it should be, but maybe not every water user in this area needs pristine aquifer water, right? Yeah, that's right. So that's just an example, I think, about being in this region. It gives us an opportunity to kind of be a little bit more forward thinking because there's so much growth, there's so much need that's coming up, particularly around water.
I can remember early on in my career, I worked at a landscaping company in the Dallas-Fort Worth area. And one of the things that they talked about doing was reusing that gray water for the irrigation of medians and flower beds and, municipal areas and even golf courses, things like that. Not that it would, be smelly or anything like that. They would treat it, of course. But to your point, it doesn't necessarily have to be drinking quality in order to be useful in the environment.
Yep. Georgia Southern uses effluent water for watering. Excellent. And I think it's one of the only places that we've at least seen so far in this area. So, kind of forward thinking.
Leaders in that regard as well. That's fantastic. What do you think is the biggest challenge in turning a promising lab idea into something that communities can actually use? And how do you and your team investigate and navigate that?
Yeah, I think that's a great question. And I think, I touch on this a little bit, but want to expand a little bit more as that, I think one of the biggest challenges in the lab is that we think that the technology is the hardest part. But that's not always the case. And that's really not what is going to determine the success of it. You can have the most efficient reactor, you can have, the smartest water sensors out there. But if people don't trust it, if there's not local institutions to kind of maintain it, or if it doesn't fit with maybe the local culture or even financial realities, it's not going to last. It's not going to be adopted, right? So I think what we've been trying to do is work more in this kind of community-centric design and sustainable design space here at Georgia Southern. And we've been trying to treat, and this is with a group of colleagues here, Dr. Francisco Cubas, Dr. Jay Sudwicks, and Dr. Helen Roscoe, thinking about how we can treat social capital also as infrastructure. So this means that, social capital and social, these ideas need to also be built, not just, the pipelines, the tanks, the treatment units. So as an engineer, that means we need to spend time in the communities. We need to learn, right, who those local partners are. And then the goal in the end, I think, is really to design with, not just for the communities and those places. So, instead of asking, can this work in the lab? How efficient can we make it? Is it, can this work here in this place for these people and over time? Yeah,
that makes a lot of sense. Bringing those community members to the table early in the discussion.
Absolutely.
To solve those problems. Well, listen, this last Saturday, I want to tell our listeners, I had the pleasure of grabbing a box of donuts and coming up to the lab and working with you and your students for a few hours. And so I know firsthand how much you love working with students. And you've even served as a faculty mentor to one of our presidential doctoral research fellows. So what has been most meaningful to you about working with students? And tell me a little bit about, do you see yourself in them?
Oh, that's a really interesting question. I think for me, the thing that's been most meaningful is kind of them keeping that bigger picture, trying to understand why they're actually doing what they're doing in the lab, right? So they can really understand why they're collecting that data, how it can be used, and the impact it has, right? The students we're working with on the compost project, they're going to collect a huge data set, right? Not for the sake of just collecting that huge data set, right? So they can ask those questions about it, understand, why they're doing it. But I think that takes time, and I think that's not always easy, and it's definitely hard, I think, as a new researcher, undergrad, graduate student even, to try and keep that big picture and to keep, that idea. So that's kind of what I've tried to do, is just keep reminding of that big picture. The other thing I try to do is, I think, trying to make it, and maybe this comes up wrong, but kind of personal for them, right? So they feel that connection to it, right? Trying to connect that human side also with the technical sides.
Well, and it is personal to them because it's their futures, it's their careers, it's their developing new ideas and really discovering new things. I think that's so inspiring, truly. So what advice do you have for students or young engineers who want to pursue research that's not only innovative, but also socially meaningful?
So a couple fold, and kind of like I touched on in the beginning, stay optimistic. It's not all easy, right? It's not a straight path. There are plenty of twists and turns. I think staying optimistic is really important, or at least it worked for me. The other thing that I think is really important is understanding the value of teamwork. Research is usually not done with one person, right? And that innovation and the impact can really happen, I think, where that, hey, I need a team to do this. I can't do this myself, right? And you're not afraid to ask those things. So I always encourage students to do that. The last thing that I kind of try to encourage students to do, and this comes from my postdoc advisor, Dr. Jeremy Guest. It was kind of funny. I got the postdoc actually through seeing it as a tweet on Twitter, and it was shared and, connected with him, and it worked out. And the interview, the last question he asked is, what impact do you want to have on the world? And that's kind of stuck with me. And I always try to ask that question to students when I get the opportunity. So I usually start off the classes by introducing myself, and then I kind of, mention this slide, hey, what impact do you want to have on the world, right? So, everybody only has so much time in the day, right? And that's one thing that I think that question makes you realize. The other thing I think it makes you realize is that, wow, I can have an impact on the world, right?
It's exciting.
And I think that's something that's really, really important for students, for researchers to realize, right? Even a small research project, even a small, set of experiments can have a big impact.
Absolutely. Well, and it sounds cliche. You touched on it early on, but I use the phrase all the time, teamwork makes the dream work. And
Absolutely.
It is so true. It really is so true. Well, listen, to wrap up today, I've got just a couple of fun questions for you. Tell our listeners one interesting thing about you that they would not otherwise know simply from following your research.
So I said the path isn't linear, right? So in undergrads, I went back and forth about if I wanted to be a ceramic artist or if I wanted to be an engineer.
Okay. So you've got some artiste in you.
So I haven't in a few years because I been obviously very busy with being here at Georgia Southern, also with a family. But ceramic art and pottery has always been a passion and kind of hobby of mine. So I went back and forth in undergrad a lot. Every semester in undergrad, I took a ceramics class.
Okay.
So it's been a big passion of mine and something I considered a total career shift to become a ceramic potter, but decided, I did the math and said, I'd have to sell a whole lot of cups.
A lot of cups.
To make
That's right.
it worth
That's right.
it.
Well, I will say, just in fairness, that we do have a potter's wheel, and we have a kiln, and we have a lot of clay on this campus. So if you ever get the inkling to do that, I know our friends over in the arts would love to help you with that as well. So that's fantastic. And finally, where can our listeners go to find more about your research?
Come visit us in the lab.
Okay.
Yeah.
Yeah.
So our labs are over in ERB.
Do you have a website at all? Or?
Yeah, Rowlesresearch.com as well.
Okay.
And my email is just my name, lrowles@georgiasouthern.edu. So feel free to reach out. We're always interested in getting folks in the lab, whether it's on a smaller project or want to jump in with both feet into something bigger.
Excellent. That is just so amazing. Stetson, thank you so much for being with us today. I truly appreciate you being here. And until next time, may your curiosity run as deep as the roots of research at Georgia Southern University.